here we are looking at some notes for section 7.5. Honestly, these notes should be review for you, and that's why I had you try some of these problems out last night at home. This is just basic matrix operations. We'll be adding, subtracting, multiplying by a scalar, but then also multiplying matrices together. And that's really more where it gets to be challenging is when you multiply them together. So let's get into it here. You have the note sheet with you that matches this video, so you should be taking down all the notes as you go. So to start with, we have two matrices are equal if they have the same order. And by order, we mean how many rows and columns the matrix has. So most of the matrices we've been working with so far are 3 by 4. And you guys remember that that first number represents the number of rows. And the second value in that order represents the number of columns. And remember that the rows go across. We have 1, 2, 3. There are my 3 rows. And then columns run vertically. So here you can see that we do have 4 columns. So I would call that matrix there a 3 by 4. That is the order of it. So now we have, what would make two matrices equal? Well, they have to have the same exact order, but besides that, all of the entries in the same location need to be equal to each other. So if you look at the given matrix A, well, it's a 2 by 2. If I wanted to write a matrix equivalent to that, I'll just set up a matrix that's also 2 by 2. And now what I'm going to do is just see if I can simplify any of these entries or write them in a slightly different way that's still equivalent to the original. So you see, well, square root of 9 is 3. Then for the 2, you don't need to change every entry. Even if only one was changed to be equal, that would be fine. But hopefully you're looking at that opposite of -3 and thinking, well, that's the same as +3. And then 9/2, again, we could leave that be, or we could write that as an equivalent decimal. 9/2 is equal to 4.5. Moving on, now we are going to add and subtract matrices. And really, this is just kind of intuitive. Even if I didn't say anything to you guys about this, I bet you'd be able to complete these problems on your own. Plus, you do have your calculator with matrix capabilities, so you're always able to check it there. But honestly, I think it's more time-consuming to have to enter these things in and add them with the calculator than just doing it on your own in your head or just the simple calculations in your calculator. So when adding or subtracting matrices, they must have the same exact order. And then what you're going to do is just add or subtract, depending on the problem, the entries that are in the same location. Now we have this next bullet point. When multiplying a matrix by a scalar, you're pretty much just going to distribute that scalar to all the entries in the matrix. And that will not make the matrix order change at all. That order will stay the same. So if you wanted to see a little example of what this would look like, let's say with both things, here would be an example. First, I'm going to multiply just according to order of operations. I'll distribute the 3 to all the entries in the first matrix, and I'm also going to distribute the 6, that's the scalar, to all the entries in the second matrix. Now we're just left with addition, and we're going to double check that these matrices are the same exact order. They are. They are both 2 by 2 matrices, so we are just going to add the entries that are in the same location. So since 3 is in the top left corner, and then -6 is also in the top left corner of the other matrix, we'll add those together. And then you just keep moving forward. So the 0 and the 48, those are in the same position. They're both top right corner. So we will add those together. And our answer will still be a 2 by 2. It'll have the same order as the matrices you're adding together. There you go. Your final answer is that matrix with the entries -3, 48, 30, and 21. So now moving on, we see that we have more of the challenge, which is multiplying matrices together. And this is where you have to be careful, because even though addition and subtraction, the rule was that the orders had to be exactly the same, here that is not the case. What you need to do is look at the orders of the matrices, and in order that you see them from left to right. And when you write out their orders, you need to check that the inside numbers of those matrices are equal. If they are, then you will be able to multiply. If you look at those inside numbers of the orders and they're not the same, then you're just done right there, and you're going to just write not possible. So let me just write this out so you have a visual. If I wanted to multiply a 2 by 3 matrix by another 2 by 3 matrix, you cannot do this, even though you might be first thinking you could because the orders are the same. We cannot, because look at those innermost numbers of those orders. On the inside here, we have the 3 and the 2. Not the same, so you cannot do this. But if I asked you to multiply a 2 by 3 times a 3 by 5, this you could multiply. If you look at those inside numbers, they are equal to each other. So then you need to figure out what the order of the answer or the product will be, and that is where you use those outside numbers. We know that the product will actually be a 2 by 5 matrix if we were to multiply these together. So the inside numbers of the matrices orders must be equal. And then the outside numbers of the matrices orders give the order of the product, or the answer. Okay, now we get to how do we actually do this. If you're going to multiply by hand, this is where it gets tricky. You can only move across rows in the first matrix, and you can only move down the columns in the second matrix. And as you're doing this, you're actually multiplying the entries as you slide across and down that row and column. You're multiplying and adding as you go. So we're going to try this out here. A little bit tricky at first. Don't forget, you can check your answers with your calculator. Don't forget that part. Okay. So I have this example with matrix A and matrix B. First, I'm being asked to multiply A times B. So I'm going to write them out next to each other. A first, B second. Now I'm going to check if I even can multiply these. The first matrix is a 2 by 2. Second matrix is a 2 by 2. Aha! Inside numbers, they are equal, so we can do this. Now let's see what the order of the answer will be. The answer will be a 2 by 2. So we have 4 entries inside of there that we need to find, and here's how it's going to work. I'm going to, in order to find this entry here, that's in the first row and in the first column, that means I will be moving across the first row in the first matrix as I move down the first column in the second. So I would multiply 4 times 5. Then I would slide and multiply 2 times negative 3. So what I actually have is 20 plus negative 6. That gives me 14, so that'll be the entry in the answer. Now let's see what would happen if we wanted to find the next entry in the answer. So now if I wanted to find the next entry in the answer, notice how that location is the first row still, but the second column. So that's how I know which row and column I'll use in the matrices I'm multiplying. I'll go across the first row, then I'll go down the second column this time. So I start at the left and at the top. 4 times 0, and slide your finger along both arrows, and then we'll be doing 2 times 1. So we'll have 0 plus 2, that gives us 2, and that's the entry that goes in that last spot. Now I'm looking to find the next entry in the product, and notice how it is in the second row and first column. So that's how I know this time I'll be going across the second row, but down the first column. So I'll be multiplying 1 times 5, and slide your finger along both arrows. Multiply these together, negative 3 times negative 3. Calculate that out, you'll have 5 plus 9. So 14 is the entry we're looking for. Finally, for the last entry of the answer, you notice it's in the second row and second column. So that's how we know to find this entry. Second row, second column. We'll go across the second row, but down the second column. So I'll be starting with the 1 and the 0, 1 times 0. Then slide your fingers along both arrows. Now you're at the negative 3 and the 1, so multiply those together. That means we'll have 0 plus negative 3. That gives us negative 3, and then that's that missing entry in our answer. So perhaps pause this right now and see if you can try out multiplication the other way, b times a. When you're dealing with matrices, order does matter, even with multiplication. So even though just with regular algebra, 2 times 3 is the same as 3 times 2, you get 6 either way. With matrices, matrix A times matrix B is different than matrix B times matrix A. So order does matter when you are multiplying matrices. So go ahead, pause this, try to multiply matrix B times matrix A, and then check the answer. Good luck. So here you are. The answer should have been a 2 by 2 where the entries are 20, 10, negative 11, and negative 9. And then you can look all my little notes below that of how I came up with that. But again, you're always moving across the first matrix and down a column in the second matrix. You are only allowed to do that. It's across and down, across and down, across and down. Only across a row in the first matrix, and you can only move down a column in the second matrix. Those are the rules of this game. Now I want you to go onto the back and try all the problems on your own. then you can check and see how you did.